How to derive firm's labor demand curve as a function of wage rate, and how to find out the profit maximizing employment level, and how to graph the labor demand curve. We will find all the stuff in this video. The question is, a perfectly competitive firm sells its product at a price of $4 per unit and has a production function as Q is equal to 200L minus 5L square. Q is the output, L is the units of labor employed. We have to derive the firm's labor demand curve as a function of wage. Also, we have to find out the profit maximizing employment level at a market wage of $80. And we need to graph the result also. Okay. So let's go one by one. So first thing is we need to find out the labor demand curve. Okay. So first thing, what will we do? We will find out the profit maximizing employment level. Okay, employment level. Okay, what is the condition for the profit maximizing employment level? The condition is pretty simple, and if I write it here, it is that so profit maximizing employment level will require that price times marginal product of labor should be equal to the wage rate. Okay, so we need this very condition in case of perfectly competitive market. Profit maximizing employment occurs at a point where price times the marginal product of labor is equal to the wage rate. Okay, so first thing is we need to find out the marginal product of labor, and marginal product of labor is very simple. It is simply the change in the output due to the change in the units of labor employed. That is the derivative of the given production function. Okay, so the derivative of L will be 1. We are left with 200 minus derivative of L square is 2L, so 2 into 5 is 10L by power function rule. Okay, so we have 200L minus 5L square. Its derivative is simply derivative of L is 1. We are left with 200. Its coefficient minus 2 becomes coefficient, so we have 5 times 2L to the power 2 minus 1, so it becomes 200 minus 5 2s are 10L. Okay, we are applying the power function rule, which says if we have x raised power n, its derivative is n times x raised power n minus 1. This n becomes coefficient and this n is subtracted by 1. Okay, exponent becomes coefficient and it is subtracted by 1 also in the exponent. Okay, now using this condition, so that implies W is equal to, we have price that is being given us here $4, so let's write it here 4 times marginal product of labor, which is equal to 200 minus 10L. Okay, solving further, so we will get W is equal to 4 2s are 800 minus 4 10s are 40L. Okay, let us solve this for L, which implies 40L is equal to 800 transposing it becomes minus W. I have interchanged it here. Okay, it was not required, so let us bear it now. So dividing both sides by 40, so we will get L, or let's write it here, L is equal to 800 upon 40 minus W upon 40. Okay, which implies a labor demand function will be equal to 0 0 gets cancelled. We are left with 20 minus W upon 40. This is our labor demand curve. Okay, so next we need to find out, and here you can see labor is a function of wage rate, which was required here, that is to derive the firm's labor demand curve as a function of wage rate. Next we are supposed to find out the profit maximizing employment level at a market wage rate of $80. Okay, so simply plug the value of W, market wage rate, here. We will get profit maximizing level of employment level, that is the units of labor employed at profit maximization, will be equal to 20 minus W is being given as 80 up upon 40 here we have, so we will get 20 minus 2, which comes out to be 18. Okay, so 18 units of labors will be employed at a market wage rate of $80. Third part tells us to graph the labor demand curve. Okay, so to graph the labor demand curve, let us solve this labor demand function for wage rate. Okay, for simplicity. So can we do one thing? Okay, we don't need to solve it here. Here we have W is equal to this stuff. If I write it like this, so W will be equal to 4 2s are 800 minus 40L. Okay, so our W is equal to 800 minus 40L. So we have solved this function for W. Now we can draw the graph. So let us draw a simple graph. We have units of labor employed on the horizontal axis and market wage rate on the vertical axis. Okay, here you can see, when, let us write here wage rate, and here we write the units of labor employed. So when wage rate is equal to 0 in this equation, when L is equal, sorry, so let us first write the labor. Okay, let's write units of labor employed, then wage rate. When 0 units of labor are employed, so L is equal to 0, so this term becomes 0, W will be 800. Let us say this point is 800. Okay, now let us plug another value for L. Let us say L is equal to 10 this time. So when L is equal to 10, this equation becomes W is equal to 800 minus 40 into 10. It becomes 800 minus 400, which is equal to 400. Okay, so when units of labor employed is 10, so wage, am I doing it correctly or not? Okay, so wage rate will be equal to 400. I hope I am doing it correctly. Now let us say units of labor employed is, let us say 20, and if I draw it here, so when 0 we have this, when L is equal to 10, so wage rate is equal to 400, so we have this point and this point, and when L is equal to 20, so here we have 20, W will be equal to 800 minus 40 into 20, so it becomes 800 minus 800, so W will be equal to 0. So when units of labor employed is 20, so we will get here wage rate will be 0. So if I draw these pointers, I will get the labor demand function, labor demand curve. Okay, so profit maximizing level of employment level was, where do we, 18. Okay, so when wage rate was $80, let us suppose it is here 80, units of labor employed was equal to 18. Okay, I hope I make myself clear in this video and you find out this video helpful. Thank you.